Hi everybody and welcome. Today we're going to be focusing on transformations and the order in which we do transformations. So your goal after watching today's video will be able to take a look at a function, identify its transformations, and identify the order in which those transformations happen. One thing that I do want to say about today is there is no formula. There's no process for doing this. There's no specific right way. There's no guarantee that you're going to get it on the first try. So this is one of those basically types of setups in math where we're using our critical thinking quite a bit. We're using trial and error quite a bit. And even if you do just transformations for the next 10 years and that's the only thing you do, you're still not going to know the order the first time you look at a function. So with that being said, go easy on yourself, give yourself some grace, give yourself some extra room to basically write down the same question a couple of times, because like I said, there's no way to know this on the first time. So just prepare yourself for the fact that we're going to be taking a look at these functions and basically going through a few times to see which way works, sometimes which way doesn't. So with that being said, we're going to jump right in, and we have some words for today. So when performing transformations, on functions, the order of our shifts matters. But how do we know which order to go in? Well, the answer depends on the types of shifts we perform. So vertical shifts impact the order of other vertical shifts. So if you see multiple things going up and down, multiple vertical orientation changes, the order of those matters. If you do them in the wrong order, it's going to give you a different result. The same thing goes with horizontal. So horizontal shifts also impact the order of other horizontal shifts. So if we have multiple shifts, in this same orientation, we have to pay close attention to the order we shift our functions. If we have one vertical and one horizontal, so if we're seeing shifts in different directions, the order does not matter. So different directions, no impact. Any shift, even if it's just two in the same direction, it makes a huge difference, the order in which we go in. So when we look through these, the way that we determine this is, like I said, by trial and error. So step number one, identify your original function. So if you still have your note pages from 1.1 where we talked about our basic function types, all we're looking for is what is our original function before it went left, right, up, down, or was a skinny function or was stretched. So here, if we just ignore basically all of the numbers and we just look at our variable, our original function is the square root of x. And the second step that we want to do is we want to identify the shifts that happen. And that's what we worked on quite a bit last week. So we have two shifts here. One is going to bring us 2 to the right, and the second is going to bring us up by 7. So 2 to the right and up by 7, what we can see here is we have shifts of different orientations. So one is left, right, one is up, down. So because of that, the order actually doesn't matter here. We are allowed to go in any order that we like because they are shifts of different orientation. So any order is fine. So you can say 2 to the right first, 7 up second, or you can also say 7 up, 2 to the right. Both of those are the same thing because we're going in different directions. So that is totally fine. So the first one is a nice example of basically if we pay close attention, we see that we're going in different directions, we're going to be totally fine. Example number 2, so let's identify our original function here. So original function, get rid of all the numbers, just leave it with the variables, is just the root of x. Second, what shifts do we see? Well, we see that we go down by 5. And we also see that we have a vertical dilation or a vertical stretch of 2, a factor of 2. So these are actually going to be basically both vertical shifts. They both go up and down. So the order that we do them in matters. And let's take a look at what that means. So we'll call this attempt 1. Let's say that we try to do our shift of down 5 first. So we start off with our function, and then we say, okay, on step 2, we're going to shift it down by 5. So a downward shift of 5 means we just subtract 5. Okay, so far so good. And then now, for step 3, we're going to take what we just did up top, and we are going to do a vertical dilation of 2. So remember, vertical dilation of 2 means we multiply the function by 2. So when we do this, we end up with 2 distributed into both terms, 2 root x minus 10. Well, if we take a look at what we just did, and what we started with, they are 2 different things. So unfortunately, going in this order does not work. So sorry, attempt number 1, but you are not what we are looking for today. So we can go to attempt number 2. So again, start off with our original function, except this time, instead of doing our downward shift first, let's try to do our vertical dilation of 2 first. So multiply the entire function times 2. Well, the entire function is just the root of x, so we did it. And then now we can take what we have and subtract 5 from it to go down. So we take a look, we have a match. So we find that attempt number 2 works. So we did it in the correct order. So our order has to be vertical dilation first, and a shift of down 5 second. So that is the order that we have to go in. If we don't go in this order, we'll get a different function. So a different function is not the right answer. And that's actually how we do these questions. You start off with your original function, and you make the shifts to the original function, and you're just looking for a match. Now, once we get beyond just having 1 or 2 quick steps here, the challenge is we're going to have to do a whole bunch of guessing and checking until we get our first green matches green match. And sometimes you might have a match that works that your partner didn't do in the same order, but they also have one that works. So what you'll see is sometimes you'll have like 20 different answers that could all be correct, but maybe 1 or 2 that don't work. And that's a challenge for the skill. So as long as you're going through these attempts, you're going 1 step at a time, you're going to be in great shape. The second skill that we have for this is after we identify the order that things have to go in, we start moving points around. So sometimes we have to perform calculations based on the shifts that we perform. So this involves taking an individual point and following the steps of our transformations in order from that point. So we'll start off with our first example here. And actually what you'll notice is, and I did this on the practice today too to try to save you some time, the questions are the same. So if you look at example number 1, these are the same questions. So we actually know that for this one already, we know the order. So either of these work. So I'm just going to write that down real quick. So we'll say 2 right, 7 up. And that order is one of the orders that work. So there were other orders that worked, but I'm just picking that one so you know that order works. So they give us an ordered pair of 9, 3. So x is 9, y is 3. And that's on the original function. So we want to know, where does this point shift to after our transformations? So we start off to the right 9 and up 3. And then from here, we can perform those shifts. So visually on a graph, if we go 2 to the right, we end up at 11. That's our first shift. And then we go up by 7. So from 3 up to 7 gets us up to 10. So 11 comma 10 would be our new point. So that would actually be the final answer here. The second way that we can do this is we know that a shift of 2 to the right would be x plus 2, and a shift of 7 up would be your y value plus 7. So you can actually use that formula and take that point. So 9 plus 2 comma y is 3 plus 7. So again, we're just taking x, replacing it with 9, taking y, replacing it with 3, and that would also get you that same ordered pair of 11 comma 10. So our second one here, 2 root x minus 5, 2 root x minus 5, we determine that we do a vertical dilation by 2. So step 1, vertical dilation by 2. And then step number 2 is we go down by 5. So 4 comma 2 is our original point here. So what we're going to do is, from this point, we're going to see that a vertical dilation by 2 just means you take your y value, multiply it by that factor. So in this case, multiply by the factor of 2, because that's the vertical dilation. And then for down 5, we can say, again, take our y value. So a good check here is we're doing multiple operations on our y values. That's why this matters so much, the order, because we're doing it on the same term. So y value here, and we're going to subtract 5. So our y value is 2. So step number 1 is we're going to multiply by 2. And then step number 2 is we're going to take that and we're going to subtract 5 from it. So we'll end up with a value of -1. So our new shifted point should be 4 comma -1. So that's how we work through our transformations here. So step 1, find the order, and then step 2 is basically take your point and walk it through that order one step at a time. So be careful on the multiple attempt type questions here. Those are going to be the ones where it can be a bit of a challenge just because you're guessing and checking until you get to the answer that you're looking for. So hopefully this video is helpful. We're going to do actually more practice on this tomorrow, so we're not going to do another new classroom skill tomorrow. We're going to take the opportunity just to do some review from this. So again, hope that helps. Time for those practice questions.